Hi, I'm Chris with Sanderson Test Prep, and in this video we're going to talk about another aspect of optics, which is when we have real versus virtual images. So, as you might have seen in our last video, we talked a little bit about this equation for magnification, which is negative I over O. It's relating the image to the object. And the negative in front is actually very important, and especially if you're looking at this on most physics tests that you'll see from high school through college to challenging standardized tests like the MCAT. Whenever you have this physics concept tested, it's very important that we understand how these relate to each other. So for real versus virtual images, that all has to do with the value of I. And when I is positive, that means that you have a real image. And when I is negative, that means that you have a virtual image. Now, in our last discussion, we talked about values for M, and we talked about what that means for positive and negative. And so I'm just going to add those here so that we can see how these will all pair up. When M was negative, which is what would happen if I is positive, then you'll end up with a negative value for M, which will be an inverted image. And when M is positive, which is what happens if you plug in a negative for I, you'll end up with an upright image. There are exceptions to this, but for most tests that you see in something, if you're especially just learning this anew, it's helpful to think of these pairings as real and inverted, and then virtual and upright, because you'll almost always see those paired together. There can be a complex system of lenses and mirrors in which at a certain point you're using a negative object distance for one, but that's very rare. So for our purposes today, for this introduction, I just want to make sure that we try to associate those in our mind. In most circumstances, you'll either see a real inverted image or you'll see a virtual upright image. So if you're taking a test like the MCAT and you see 4 answer choices with real inverted, real upright, virtual inverted, and virtual upright, you can eliminate real upright and virtual inverted. Those will almost never be correct. In MCAT context, I would actually go to say that those will never be correct for most of the MCAT questions that you'll see. Now, what does this actually mean in practice? So when we talk about a real image, what does that mean? Well, a lot of times when you're first learning physics, you will see, when you get to that optics chapter, some of the first visuals that you'll see, they'll tell you that you have an object at a certain distance, and you'll see that you have some sort of mirror or lens, and then it's going to have a certain type of concavity, and you're going to have to draw these rays of light that are being reflected by the mirror through a focal length, and then through the focal length back parallel. You're trying to figure out where is that image being formed, and this where they intersect would be the image. So this is great, and this is really helpful to understand where the light is traveling conceptually. However, it's extremely difficult to really get exact values based on drawing out these types of diagrams. And in a testing context, what I want to do for right now is look at this a little bit more mathematically. And so if we look at a real image, so think of real as the image is formed where you would expect the light to go for either a mirror or a lens. But image is, I like to say, it's where expected. So if we think about what that means, let's talk about a mirror versus a lens. And you can think of something as simple as a plain mirror that you would see in your bathroom, or you could think of a contact lens, any sort of mirror or lens. But if we look at the two, so for a mirror, we would expect the light to be reflected or pass through it. So hopefully if we think of a mirror, we think of light being reflected or bouncing back off of that mirror. And so that means that a real image for a mirror is going to be on the same side as the object, because that means that the light has reflected off of that mirror. For a lens, it would be the reverse. A real image would be on the opposite side as the object. So it's opposite of the object because if, again, we think of what we're expecting to happen with light with a lens, for a mirror, we're expecting that light to hit it and bounce back. For a lens, think of like a contact lens, we're expecting that light to hit it and then continue through. So in terms of value, both of these would be indicated by a positive value of I. The math doesn't change on it numerically, but I just wanted to highlight what the actual meaning is. When you have a real image, it means it's ending up where you would expect the light to travel for that given surface, whether it's a mirror or a lens. And then for a virtual image, it's going to be the exact opposite. So here, virtual image would be, it's the image being formed where you would not expect the light to end up. So in this case, for a mirror, it would be on the opposite side, and for a lens, it would be on the same side as that object. So that's what you would see for virtual images. But the easiest way to do it is just pick only one that you have to memorize. So here, memorize where those relationships would be for a real image to be formed. And if we understand that interplay between magnification and the corresponding value of I, then that is enough foundation for us to understand most mirror and lens systems in optics. For more, please check out our other videos, and thanks for watching.